Hello everyone, it is 12:08. It says July 19th, but don't worry about that. This is for July 18th. I mean, we're just 8 minutes past, 9 minutes past now. But I mean, this is for July 18th, for Friday, so it's a little late to record in this video. Today we're going to start math and geometry. Probably going to be stuck on these and probably going to have to kind of ask for help or maybe hints or whatnot to get myself out of these. Same way I did with bit manipulation. I highly doubt that many interviewers are going to use questions like these, but we shall see. You are given a n by n 2D matrix, so it's a perfect square, representing an image. Rotate the image by 90 degrees clockwise. You have to rotate the image in place, which means you have to modify. This just requires simple matrix multiplication. So, matrix multiplication calculator. How to rotate a matrix 90 degrees clockwise.
Mom, what's that?
Nothing. Just get in the car. Let's go. Come on.
Oh,
Second row
think instead that skip
is the second column over here. So we have successfully transposed the matrix. And now if you see, it's 13951. So it's the reverse of this. Now what you will do is, you will reverse every row. You will reverse.
Hey buddy, you a good kitty. Let's see. So he transposes and then reverses each row. Interesting. The transpose is going to be n squared, the reverse is going to be n squared, so 2n squared, but I mean, is that really the answer? I don't think so. I feel like there's probably a much more cleaner solution. We can rotate the matrix in two steps. First, we reverse the matrix vertically, meaning the first row becomes the last row, second row becomes the second last, and so on. Next, we transpose the reverse matrix. Oh, okay, so it is that. Okay. All right. Well, good to know. So I need to build. I can do either or, really. I feel like. Hey, stop it! Hey! And you motherfucker! Just put holes in my shirt, man. Chill. Yeah, you got it bad. What the hell, man? You have a scratch pad, bro. I don't know. Sorry, my cat was scratching my work shirt. Oh, also, I did get a comment the other day. Someone was asking about my mic, so I'll try to be closer to the mic to be louder. So hopefully this will be better. Maybe right here. This will be better probably. Thinking about getting a better mic so that way I don't have to worry about sounding super quiet. Hey, relax. What's up, man? What's up? What's up? Okay, so I'm gonna make two functions. I'm gonna call this reverse matrix and everything's gonna be done in place, so I don't have to worry about really returning anything. So I'm basically gonna go for we're gonna go left equals 0, then right equals length of matrix. You say while left is less than right, say temp array equals matrix of left, and then I'm going to go ahead, I'm going to say that matrix of left is going to be equal to matrix of right. I'm curious if this is going to have, you know, the typical Python errors, and then matrix of, with typical Python errors of the array memory being kind of what's the word? C++, whenever you call a function with the and sign, can't remember, but it's kind of built into Python, so I'm curious to see if that'll happen. Although we're not doing any recursion, so I guess I don't have to worry about that. So we should be fine. Okay, so this should just reverse it. This is a two-pointer approach. It's just a slightly faster approach of doing it. That's linear. Well, linear-ish. I don't know. I'm guessing maybe moving the whole memory. I feel like moving the memory allocation. Maybe if this is a pointer, it would be better. I look need to stop coding in Python because I feel like it's rotting my brain out where I'm not truly understanding the time complexity of things just because they have so many simple solution things. Okay, we're going to make the transpose. Now with hey bud, what you doing? With transpose, I'm gonna have to make the columns turn to rows and the rows turn to columns. So I have to make some sort of algorithm for that. I'm thinking we could do something kind of like. Hey. Ow. Quit it. I'm thinking we could do, are you doing it again? Relax. You have to. Hold on. Max, please. You have a scratch pad. Stop scratching my stuff. Stop it. Let it be. Leave it alone. Oh, you're so mischievous. You're doing all this chaos so you can steal my chair? I can just pick you up, bro. You're not that heavy. Yeah. You win, you can sit in my lap. Now my cat will be on my lap while I'm programming, so you might hear him on the mic. Can I say something on the mic, Max? Let's see. I honestly think a simple solution could be trying to think. What's that? Wow. 0, 0, 1, 0, 2, 0, 3, 0, 0, 1, 0, 2, 0. Okay, so here's my idea. For index I in range of length of matrix for index J in range of index I plus 1 to the length of matrix. Okay, and then this is where we can do our swap. It's honestly a pretty simple solution algorithm. I think this is kind of I would assume this is pretty decently well optimized. Not really doing that many operations. It's kind of almost, it feels almost logarithmic per se, but I could be wrong. I am wrong. There's probably no way that's actually, not that the whole thing's logarithmic, but like maybe n log n. We'll see. I gotta probably spend some time looking into just being able to look at a function, being able to determine its runtime complexity. Stuff like that just feels kind of okay, so we say temporary variable. We'll just call it tip bar. Tip bar is going to equal matrix of index I, index j. then xi of xj is going to equal to index. Oh, interesting. Equals temp to bar. Okay. So that should transpose. Nice. So if I run something like print matrix, and then I did reverse matrix, and then I printed matrix again, and then I did something like transpose, then I did print matrix again. Let's see what we get from this. See if we actually get anything of use. Matrix of left equals matrix of right. That makes total sense because I did that incorrectly. It needs to be -1. Transpose. Spelled it wrong. By the looks of it on the call stack, hey, accepted. $79, 456, 137. Yep. Cool beans. Works out pretty well. Let's see how it runs on submission. See if it has any concerns on the time. Nope. Passed with flying colors. That one was honestly not too bad. That one does require knowledge of linear algebra a bit. Not really. Not really. Let's see. I'm gonna give this one probably like a short try, and then I'm gonna, if I can't get to this, I'm gonna have to save this one for tomorrow. I still have kind of an early day tomorrow. I need to continue working on my project a bit over the weekend, which is, you know, how it goes. Given a m by n, so it can be not a square, it can be a rectangle. Return elements of the matrix in spiral order. This really does not feel that challenging per se. The way I would do this is I would make a checker. So kind of like how I would do this with DFS. If you land on a square you've been before, reverse, and then you need to turn right. Or if you go out of bounds, reverse and turn right. So I'm going to say okay, so I know how to solve this one, but I'm trying to see if I can solve it cleanly without writing a bunch of gibberish, you know, making it unreadable. So I could do something like depth spiral, and I could just say like current element, or I could do row column. I think that one would be better. And then I can do something like visited equals that. It's probably actually not really desired to have a visited array, because you could probably just do this with O1 space. Yeah. Maybe not a visited. Maybe visited's not preferred. I know I can do this without a visited, honestly. I can just augment the matrix. It's pretty, not really smart to augment the matrix, but, you know, we do what we do. So I'll say if row is greater than length of matrix, or row is less than length of matrix, that's gonna happen. Or column is greater than length of matrix of the first matrix available. Or column is less than 0. Whoops, I meant to put less than 0. Sorry about that. Or a matrix of row column equals none. Then we rotate, but that's not actually really a good idea. I'm wondering if there's like a mathematical way of going about this. Like a counter per se. Like I go 4 here, 3 down, 4, 2 up, 3 down. I bet this is actually pretty easy and just not getting it. I mean, okay, so if anyone's confused, this is a very simple problem to brute force. So I'm not confused on how to do that. I'm confused if there's a clean, elegant mathematical solution. My goal in this situation is not to brute force it and then just try to solve it without understanding it. I kind of want to understand what's the proper methodology in case if I get something similar to this, I don't just answer in the brute force kind of solutions over proper implementation idea. honestly, I'm not gonna lie. I'm gonna work on that one tomorrow. I don't think it's hard. I've just feeling a really sleepy right now. We'll look at that tomorrow. But let's hopefully tomorrow we'll try to see if we can do a non-brute force approach so we don't waste energy. Anyways, thank you for watching. I will see you tomorrow.